Welcome back to our journey with TypeScript. In the previous class, we learned and understood how classes act as blueprints, how inheritance helps us build specialized robots from base designs, and how access modifiers control who can access which parts of a system. All of this helped us design well structured, secure, and reusable robot models inside our robotics lab. In today's class, we take this one step further. So far, every blueprint and rule we created was for a specific type of robot. But in a real robotics lab, engineers also build universal tools and containers that must work with any kind of robot or component without knowing in advance what will go inside them. This is exactly what generics in TypeScript help us achieve. Just like a universal storage box in a robotics lab can hold any component safely while still knowing what type of component it contains. Generics allow us to write flexible, reusable, and type safe code that works with any data type. Let's now explore generics through this same robotics lab analogy. So I'll show you with a code. Mm, let's say I have a function that is store in locker, which is of type T, uh, item of type T, which is of type. Just return the item here, right? Tool, yeah, string range, and let energy equal to storing locker number. Yeah, 100. We'll keep this. Yeah. So over here, what I've defined is I've defined a function named as store in locker. So as you know, in a locker, we can store anything. We can store tools, we can store lab codes, we can store some sensors, some, let's say, chipsets. We can store anything in a locker. So in that case, we can't actually specify what type of argument it will take. So in those cases, we use generic type for defining what type the particular function will accept. So here I've defined a generic type, and then based on the content, what I'm storing in this locker. So let's say this tool, this is of type string. So then I'm passing the string and I'm passing which tool I want to store in the locker. Similarly, in this case, this, let's say it's an energy cell or a battery, let's say. So this I want to store in a locker. So this is of type number since this battery is at 100% charge. So let's say I store this in the locker and I pass the number over here. So this is basically generics in TypeScript.
Nandan, this reminds me of any type that we learned in the first class. So, how is that different from generics?
Yeah. So like you said, the type any is also similar to this, but any we mostly use for defining of any variables. But in place of function, by using a generic type, then we can define what type we want to pass. So whether it's a string or a number. But if we had switched this to any, then we wouldn't be able to pass the string over here, the type string. Then it would accept anything. So even if I want to pass, let's say, a tool, but in place of string, there would be any over here, then it would accept anything. So it would not just wait for a string over here. It would even accept a Boolean value or a number. So we wouldn't be able to enforce that this particular argument would be a string. So that's the reason we don't use any over here. We use a generic statement.
Okay.
Yeah, so this was it. Let's look at a code then to better understand these concepts. So let us look at a library system. So let me just create a file over here, library.ts. So let me create an abstract class that is book. Now this abstract class will have a protected ID, which will be of type number. Then it will have a public title, which will be of type string. It will have a public author, which will be again of type string, and it will have a private checkout function, which will be Boolean, and by default, it will be false. Yeah, okay. Let me define a constructor now. ID of number. Then we have title of string, and then we have author of string. Yeah, this dot ID is ID, this dot title, this dot author is author. Yes, perfect. Uh, let's define abstract get description string. Let's define public checkout. This dot checkout is true, and we won't console over here. We will console later. Okay. Let's also write a function to return the book. So that is public return book. This dot checkout is false. Mhm. We'll write a function to check if that particular book is available. So public is available, which is Boolean, and of type return. Yeah, this dot checked out. Okay. Now let's create different types of books. So let's create a class for fiction books. Fiction book extends book. Yes. I have a constructor ID number public gender string. Yeah. Then I will have super ID title and author. Yes. Let's also get description, which is of type string. It will return this dot title by this dot author, and yes. Okay. Yeah. Let's copy this and create another one. Yeah. This time we'll create a science book, which will have the same this dot title, and yeah. Okay. Let's create a generic class now for library. So it's class library, which is of generic T, private items T, which is equal to an empty array. You add an item of type item, which is of type the generic T. This dot items dot push item. Let's add a get all method. Get all, which is T, which is an array, and return this dot items. Yeah, return this dot items. Perfect. Let's add a bookshelf now. Constant bookshelf. This will be of type library, and it will be yes, book, and yes, perfect. Let's add books now. Bookshelf dot add item, new fiction. Yeah, okay. And let's add a new science book as well. Yeah. Let's console log. Say book list. Shelf dot get all. So this will return an array, and we can use the for each method for each book. We just console.log book dot get description. Yes, perfect. Now let's do the checkout. So console.log. Let's do checkout demo over here. So that is constant, say first book is equal to bookshelf dot get all 0. Yeah. Now console dot log before checkout is available. Yeah. Then I'll check out the first book. Then after checkout is available, first book is available. Yeah. I'll return the book. Yeah. Okay. Okay. Let's go step by step over here. Let's not do everything. Let's first check out. Yeah. Let me run this code. Yeah. So as you can see, my book list is these. I have these two books. Then in my checkout demo, before checkout, this book is available. So the first book is available to me. Now let's do the checkout. So after checkout, mm, let's add this. Let's do this. Yeah. So as you can see, after checkout, this book is not available. So is available is false. Let's return the book now. So I return the book and let's see after returning, is it available? So yeah, I do this. And yeah, as you can see, so before checkout, it was available. Then I checked it out. Available was false. And then I've returned it. So is available is true. So this was a basic example to learn the concepts of inheritance and the abstract classes in TypeScript.
So when we talk about web applications, we talk in terms of, adjectives like safety, security, or scalability.
Correct.
So using this code from a bird's eye perspective, can you show us some code chunks which are responsible for each of these? Let's say one part of it is addressing the safety concerns, or the other part is taking care of the automation.
Sure, sure. Let me show it to you. So over here, like you mentioned, the safety concern. So that is handled by, let's say, this private checkout. So this checkout function is not available to anyone outside. So anyone, like, let's say I visit a library and I just can't pick up a book and leave the library. I will have to do this checkout procedure. So this will be handled by the librarian using this checkout function. Then, like you mentioned, the scalability part. So over here, for each book, I will have to start writing all these descriptions, all these key values actually. So for each book, it will have an ID, it will have a title, it will have an author. So for each book, each type of book. So let's say I have this fiction book, I have this science book. Tomorrow, let's say I have some comic books. So for each, if I start writing all this, it will be kind of repetitive code and it won't be scalable. So that's the reason we use this inheritance over here. So we just define a base class over here that is book, and then we extend the book. And let's say this fiction book has some attributes which are specific to this, then only those we can define over here. But all the other base attributes will be, those are common to all books. So those we inherit over here. So that is where we use inheritance to actually scale our code and also avoid any repetitive any repetition of code. Now this thing, the generic class that I've used over here. So this, let's say now library, library, I've passed the classes book over here. So that's the reason I've used a generic type over here. So here in place of the generic type, let's say I had mentioned it as string, then I would not be able to pass the book over here. So this book is actually of type this abstract class. So I would not be able to pass class type over here. I would have to pass a string over here. So that's the reason we use generic so that we can define any the particular item will be of type. In this case, it will be of type book over here. Since our bookshelves, they have of type books only. They can have of any type. They can have fiction book, science book, but in the end, it will be of base class book. So that is the reason we have used generic type over here and we are passing book over here. And here we are just calling the functions to add the books to that particular shelf.
Thank you.
Yeah. Thank you.